Find the monthly payment R necessary to pay off a loan of $90,000 at 5% compounded monthly for 30 years. And we're going to round our final answer up, not using the usual rounding rules, but rounding it up to the nearest cent. This is a typical problem in the present value section where you're computing a monthly payment. So be very careful, make sure you can do all the calculations and follow along, and you can rerun this video as many times and pause it to make sure you got it. So let's go through this very carefully. First of all, the present value formula. This formula is written a little differently than it is in some of the other texts, but the nice thing about it being written this way is that you can solve for the present value, the capital P, or the capital R using the formula just as easily, whether you're solving for either one. And the left hand side looks like something you've done earlier, and the right hand side looks like something you've done earlier, so it's sort of easier to remember the formula. The capital P is the present value, the capital R is the periodic payment, and all the other letters are exactly what they've been in our earlier problems. So let's get started. We first need to identify everything. First of all, they're asking us to find the monthly payment capital R, so that will be what we're looking for. So we'll be solving for capital R. They tell us that the loan is $90,000. $90,000 then is the present value. It's what you're borrowing right now. You'll owe more in the future, but right now the present value is $90,000. The interest rate's 5% compounded monthly. So this is compound interest. It's an annual rate, but it's compounded monthly for 30 years. So little r is 0.05. Since it's compounded monthly, little m is 12. And it's for 30 years, so little t is 30. Now really it's just a matter of plugging in and starting your calculations. So let's be careful here. We're first going to, before we go into the main formula, the one on the left here, we do have to calculate little I and little n. So let's just do those first. I'll start with n. M is 12 and t is 30, so n is equal to 360. Let's push that n equal 360 out of the way so we can use it later. And then do little I. Little I is r over m. R is 0.05 and m is 12. And if we do that division, I'll show it on the calculator. You do 0.05 divided by 1, 2 equals, and you'll get the number in the display. That's the calculator's version of scientific notation, and that -3 in the exponent means the decimal place has to be moved 3 places to the left. And we've done this many times now, so I'm not going to belabor that point, but that decimal point that used to be between the 4 and the 1 gets slid over 1, 2, 3 places to the left. Okay, that's our interest rate per period. So let's slide that out of the way so we have more room to work. Now let's just plug things in. And I'm showing you where everything came from. The capital P, the present value, is the 90,000. So that goes in here. The little I is the interest rate per period that I calculated earlier. So it goes in here. But it also shows up again here and here. So I plugged it in over here and over here. And then the n goes in as the exponent on the left here and on the right here. So the 360 is in, goes in here and here. So make sure you get all the values plugged in. Now let's clear some of that off so you can see it better. The rest of the problem is basically arithmetic. Be very careful. So let's just get started. The first thing I want to do is calculate that 1 plus value, and it appears in 2 places. So with my calculator, I will go 1 plus 0.00416666. Notice that your calculator 6 runs out of spaces before you go any further. So you just have to hit equal. You put in as many as you can. When you get equal, you get that 1.04 number. So I'll write that in both of those places. Now I want to calculate the exponent. Now you can write that down. I alluded to that. You can write that sum down as a separate step, or you can just leave the base in the calculator and do the power, and I think that's what I'll do. So I'm looking at the red circles. I'm now trying to take the base, which I already have in the display, and raise it to the 360th power. And that will go in here, and it'll go in here. So you do the power. Once you get the base in, which you already have it, you hit the power button, and then put in the exponent, which is 360, and then hit equals. And that will give you 4.467743246, and you need to plug that in the two places where that exponentiation occurred. So if I plug that value in, it goes in both of those spots. It goes in here and here. Alright, let's clear that and look. I want to keep the old calculation too, so you can go back and look at it later. So I slid this second step down and put the original calculation back on the first line. But now I want to do this product right here, the 9,000 times the 4.4 number. I won't show every little thing on the calculator because it's just something I know that you know how to do. But if you do that product, you will get 402,096.8922. Okay. I slid that down. I want to keep my old calculations so you can see them. Alright, now looking at this, the next thing I want to do is this fractional fraction over here on the right. So I want to do that. So I start off by doing 4.467743246 minus 1. I hit equal and then do the division by the little I. I won't again show that. I know you can do it. But when you do that, you will get 832.2585122, and you plug it in. Again, I want to show all my steps. So the last thing I want to do after I plug in that 832.2585122 is to solve for R. I divide both sides by the 832.2585122. And so I indicate that there. And I know you can do that in your calculator. When you do that, you will end up with 483.1394168. The problem said to round it up to the nearest cent. It's sort of covered up here. I'll uncover it in a minute. But remember, they want to just round it up to the nearest cent. So normal rounding rule says you go to the cents and look at the digit afterwards. If it's 5 or higher, you round up. They said to round up in any case. So that happens to be a 9. But even if it had been a 1, because they said round up, we would have rounded up. So when all is said and done, the monthly payment would be $483.14, rounding up to the nearest cent. This is just a standard problem, so if you're having trouble, go back and practice, rewatch this as many times as you need to, and practice makes perfect.